Load factor is a ratio of lift to weight. So if it's 1, it means that lift is equal to weight. This is the normal situation in unaccelerated flight. Even though it's unitless, load factor is commonly expressed in g's, which is reasonable because the pilot experiences an apparent acceleration of gravity equal to the load factor. The load factor increases whenever the wings need to provide more lift than the airplane weighs. Increase in weight is in all three answers, but the reason is a little tricky and we'll come back to that. The classic example of increased load factor is level turns. A steep turn, really any turn where altitude is maintained, requires the plane to provide lift to hold the airplane up and additional lift to pull the airplane around the turn. This additional lift increases the load factor at an amount that increases the steeper the turn is. At 45 degrees of bank, it's 1.4, and at 60 degrees, it's 2. Another cause of increased load factor, and therefore stress on the wings, is abrupt attitude changes. Moderate pitch changes impose little extra load, but abrupt changes, like in severe turbulence or aggressive maneuvering, can spike load factor and impose large loads on the wings. So the correct answer is A. Now let's return to the increase in weight. By itself, increasing weight does not change the ratio of lift to weight in unaccelerated flight. Lift always equals weight, and the load factor stays at 1. However, the FAA wants pilots to be aware that in dynamic maneuvers or turbulence, a plane at a higher weight experiences significantly higher structural stress and total load. So while weight alone doesn't increase load factor in straight and level flight, it does increase the stakes. Steep turns and abrupt changes in airplane attitude in a heavier airplane will impose more total force on the airframe than the same maneuvers in a lightly loaded one.